Guys, welcome to the lesson. In this lesson, I'm going to teach you about complex numbers. I'll teach you the basics. This video is the introduction to complex numbers. So I'm just focused on the basic concepts so that you can be familiar with complex numbers. And in case you're struggling to understand what complex numbers are, then this video is for you. I'll try my whole level best to make everything make sense for you. Also solve some of the tutorial questions, which are also common exam questions. Okay, of course there is a lot of more concept on this subtopic, but this video is focused on the basics so that you can be familiar with everything, so that it can be even very easy for you to learn some further concepts of complex numbers. Okay, because if I were to teach everything in the same video, the video can be very long that you can't even manage to finish watching it. Okay, so for this video I'll just focus on the basic knowledge that you need to know. Okay, so by the time you finish watching this video, you'll be able to solve this question, the first question from the tutorial sheet. You'll be able to solve this question here, and also the questions involving finding the value of x and y. You're going to be able to solve all of these questions by the end of the video. Okay, so without any further ado, let's go to the basics. Okay, so now what are complex numbers? First, let me even write it down for you. Complex numbers. Complex numbers. So I know some of you, when you hear the word complex numbers, the moment you just hear complex, you start thinking that the topic is very complex, but the opposite is the truth. Okay, oh yeah, it has some concept, it has got like a number of concepts, but it is not necessarily complex. So they just mean that the complex numbers are just like any other kind of numbers. For instance, you have real numbers, right? The numbers that you use, for instance, are the number 1, 2, 3, all those numbers that you use, they are real numbers. Okay, you have integers, those numbers are the negative integers that are found on the number line, those numbers. So just like any of these numbers, they are also what are called complex numbers. So real numbers consist of the rational numbers and irrational numbers. Of course, I'm pretty sure by now you're familiar with them. If you don't know about these two numbers, you can watch the video on this channel. There's already a video I explained about these numbers. So there are real numbers. Real numbers also consist of these numbers like 1, 2, 3, the integers. Like it consists of all the numbers that you have, okay, that we use. They are part of the real numbers, which is represented by R. So now, apart from these real numbers, which the majority of the people are familiar with, they are also what are called the complex numbers. So the complex numbers, they are somehow special. There's a reason why they are called complex. I'll tell you what this complex means in complex numbers. The reason why they are called complex numbers. So when I look at the real numbers, for instance, the number 1 is a real number, 1/2 is a real number, this is a real number. Any number that you can think of that you've been using all this time, it is a real number. But these complex numbers, they are somehow special in some ways, but in which way? So let's look at it. Okay, so these complex numbers, first, before I even go any further, when you look at the word complex on its own, when you look in the dictionary, if something is complex, it means that it has some additional features. Okay, it has some additional concepts. That's what it means when it is complex. So even these complex numbers, yes, they are like any of these numbers, but they have some additional features. There is something more to these numbers that other numbers doesn't have. For instance, when you say that this topic is very complex, it means that compared to the other topics, that topic, it has got some like other subtopic. It has a lot more subtopic. It has some additional features. So even these numbers, they are not just written like the way we write them. They don't exist like the way these two are. I mean, the way these real numbers are. So with that being said, now, what is so special about the complex numbers? So complex numbers have got two parts. These numbers, this number here, or these real numbers, they only have one part. Let's say number 1. This is just one part. Okay, 1 over 2. This is just one part. Square root of 2. This is just one part. Okay, so these numbers, the complex numbers, they don't just have one part. They have got two parts, and because of the presence of two parts, they have an additional part. That's why they called complex numbers. That's why they said to be complex. It is because of the additional part which they have. What is that additional part? So complex numbers are written in this form. They have A plus B with the symbol I. This is the additional part. So this first part is the real part, and it is a real number. Okay, this is a real part, and the other part is the imaginary part. The imaginary part. So because of the presence of these two, the other part, it is why they are called the complex numbers. They have an additional part. So unlike real numbers, which are represented by R, these complex numbers are represented by the letter Z. Yes, letter Z is also used to represent the complex numbers. Okay, so this is very important. So all you need to know is that the moment you hear the word that this is a complex number, just know that it has got another part which is an imaginary part, and this is represented with an I, the letter I, a small letter I. It represents imaginary. So A and B can be any number. It can be 1 plus 2. Okay, but for you to show that this is an imaginary part, you add the I. Okay, by just writing like this, you have written a complex number. So now sometimes they'll give it a number like maybe they just write like 2i. If they write they just show you the imaginary part, just know that even the real part is there. Okay, it's there in front. It's just that it is 0. Okay, and for these numbers which are not complex numbers, behind the scenes they have an imaginary part. They have an imaginary part which is 0i. For instance, when you just write 1, okay, this one is not a complex number because there is no I, right? It doesn't have an I, an imaginary part. Okay, so for the fact that it doesn't have an imaginary part, you just need to know that it is same as having 0i because there is no imaginary part. There will be an example that I'll solve that will require you to use this concept. Okay, so this is all you need to know. And another thing, this is just one of the ways in which you can represent the complex numbers. Okay, of writing letter Z being equal to A can be any number plus B can be any number accompanied with the I. So at your level, you use this. You use this format to represent the complex numbers. Okay, and then there is another way of representing the complex numbers. And this way is by writing, you write letter Z, then equal to. So I said this is a real number, right? So you say real, R-E, you put letter Z, plus, this is an imaginary part, right? You write capital letter I, M, and then inside you write. But at your level, they don't use this. I'm just explaining this in case maybe you read a different book, then you find that something like this is written on complex numbers. Especially you guys like studying big books, you'll be finding some of these. This at your level, they don't use it. They'll be using this format to represent the complex numbers. Okay? So this is all you need to know. So the moment you hear the word complex number, don't think that no, the complicated topic. No, they mean that it's just like any of these numbers, but for it has got an additional part which is an imaginary part. Okay, so an imaginary part should be on your mind. So now another thing that you need to be aware of is that when a number is a negative and is under a root, okay, for instance, -1, it is same as having 1i. It becomes a complex number. If you've worked with the quadratic formula, then you end up with a negative number under a root. It will mean that oftenly it is even considered to be undefined. Like in most cases, you'll be considering it to be undefined. It represents a complex number. Okay, so even if you get -2, it is same as having square root of 2i. Okay, so the reason why they consider those calculations to be undefined is because what you get is a complex number when you are working with, or when you are dealing with, or when you are looking for the real numbers, which are these standard numbers that we have been using. Okay, actually, even the scientist, or let me say the mathematician who discovered the complex numbers, was solving a mathematical problem using that formula, quadratic formula, which is neg b plus or minus the square root of b squared minus 4ac over 2a. Then he ended up, or he got at a point where he had a negative under a root. He got stuck, and he took the things personal and ended up discovering the complex numbers. Okay, to help him carry on with the calculations. But at our level, when you just reach a point where you have a negative under a root, you just say undefined, because you don't go beyond that. Okay, right now what you just learn are the basics of the complex numbers. Unless you further your studies, you're going to learn this in depth. That's why you are even going to be using this format. Okay, so apart from this, let's talk about some of the operations that you can perform on the complex numbers. Okay, so there are some operations that you can perform on complex numbers. Okay, and these operations includes the addition operation, the multiplication operation, the division operation, the subtraction operation, and the equality operation. The equality operation. These 5 operations, you'll be using them on complex numbers. What I mean by using them on, let's say maybe you have a plus bi. Okay, let's say maybe b1 a1 plus. It's like you're adding 2 complex numbers. You'll be using them when you're let's say for instance addition, right? You'll be using it when you're adding 2 complex numbers. Okay, where maybe you have this complex number plus, maybe let's say this time you have a2 plus bi2 maybe e. Okay, so what I'm trying to say is that you can add two complex numbers, you can multiply 2 complex numbers, you can divide 2 complex numbers, you can subtract 2 complex numbers, and you can equate 2 complex numbers. So you need to know this. These are the basics. You don't have to rush to the calculations. That's why you get confused, because there are some rules that need to be applied when you're adding, multiplying, dividing, subtracting, and equating. Equality, I mean using this symbol, is represented by this symbol. When you equate the complex numbers, there are some special rules that you apply, which I'm going to teach you. You need to know them. Okay, even when you're adding, when you are subtracting, when you are dividing, when you are subtracting, I mean here it's multiplication, subtraction, okay. So without understanding these, you'll be getting confused. Okay, now it's not all the operations that you use at your level, like the questions that they give you. There are some operations that you won't necessarily be using. For instance, addition, addition, you won't be using this one. And oh yeah, in the tutorial sheet you'll be using them, but for exam questions and the questions that they bring on the test, the many important ones, or the operations that you need to know to be able to solve the question that I just showed you, are the ones that I'm going to show you. So for addition, subtraction, these 2 are rarely used. Okay, but I've taught all the operations in depth in my tutorial group. I have a group where they have lessons of all the topics. video lessons actually, which you can learn at your own speed and pace. So you're going to find all the lessons. I've already taught complex numbers. I've explained everything. I've even gone beyond what I've taught in this video, what I've teach in this video, because I've I've recorded like a number of videos. If I were to explain everything, the video can be very long, like four hours long. Okay, but in this video, I'm just focusing on the basic ones that will help you to understand complex numbers and to be able to approach some questions, especially the question that I've just showed you and some of the questions in the past papers. Okay, and to help you also learn other concepts on complex numbers. Okay, so right now I'm just going to teach you this one: multiplication, division, and the equality, because we are going to need these three operations. We need to know the rules that should be applied when you are dealing with these operations. Okay, so let's proceed. First of all, I'm going to begin by teaching you how to multiply complex numbers. Okay, so imagine you've been given let's say maybe you've been given like 1 plus 2i, okay, times 2 times 3i. So they want you to multiply these two complex numbers. This is a plus bi. This is a plus bi. Okay, you have two complex numbers multiplying. So before I even proceed, there is a certain identity. The identity which is when you have I squared, it is same as having -1. Okay, now where does this come from? So the guy who discovered the complex numbers, you remember when I said that if you have a negative under the root, it is same as having 1 with the I. It is same as you have you have this as a complex number, right? So now imagine if you were given this and you were taught to simplify this further by just having I as your subject of the formula. How can you do it? So here you have 1 which is under the root, right? The square root of 1, it is 1, right? So here you're just going to have 1. Here there will be 1i, okay? And here you're still going to have the negative there, right? So, okay, so now is there another way in which you can write this? Let's say maybe, okay, I don't want to have a square root on this side. How can you get rid of the square root? How can you get rid of it? So you're going to square both sides. When you square this side, this is going to cancel, and you're going to remain with -1. And here you're going to have I squared. Okay, 1 squared is the same as having 1. So you can just write like this. So this is where it came from, this identity. You'll be seeing it oftenly. So what I mean by identity, I mean that while you are simplifying your complex numbers, if you happen to be at a point where you have I squared, you should replace with -1. And this is where it comes from. Okay, I don't mean that they'll ask you to drive this. No, it's just for teaching purposes. I just want you to understand and not forget this. Okay, now let's go back here. So when you're multiplying the complex numbers, you do it the same way you handle algebraic expressions. For instance, when you are given, let's say you're given x plus 1, you have times 2 plus x. What do? You just do that. Okay, you multiply x times 2, right? You're going to get 2x. X times x, you get x squared, right? And then you do 1 times 2, you get 2. 1 times x, you get x, right? You add the like terms, you're going to have 3x, and then you're going to have plus x squared plus 2 x squared. Rearrange the like terms, all those stuff. The way you use to handle algebraic expressions. This is algebra, guys. So the same way you handle algebraic expressions is the same way you even handle when you're multiplying the complex numbers. Okay, it is different from addition and subtraction, even though it is out of the scope of this video. Okay, so now let's solve this question here, or this example that I've just given you. Let's go back and solve it. Now that I've explained what I'll be using while solving this one here. If you haven't understood anything here, you need to rewind the video and watch again, because you get stuck. Okay, so this is what we're trying to solve. So So like I said, the same way you handle algebraic expressions is the same way you handle when you're multiplying two complex numbers. So you're going to do this. 1 times 2, that is 2, right? 1 times 3i, that is going to give you 3i, I representing the imaginary part. So now you come to this one here. 2 times 2i times 2, you're going to get plus 4i. 2i times 3i. Remember, you have 2 i's like terms, so you're going to have 2 times 3, that is going to give you, it is going to give you 6. Since this I times I, it is going to give you I squared. Okay, so the moment you just see I squared, this should come in your mind, the negative one, the identity. Okay, so first you're going to replace the I squared here with the identity, which is like this. I squared is equal to negative 1. Okay, so you're going to have 2 plus 3i plus 4i plus 6 negative 1. Okay, so now you're going to have 2 plus 3i plus 4i plus, actually here you're going to have negative 6. Okay, since here it is negative times positive, it will be negative. Now you add the like terms. 4 plus 3, that is going to give you 7. Okay, so in fact, first arrange the like terms. So you have 2, this, take it here, you have negative 6, and this plus this one is going to give you, it's going to give you 7i. It will give you 7i. Okay, and this one is going to give you negative 4 plus 7i. And normalize putting the imaginary part on this side because of the format a plus bi. A plus bi. Okay, so normalize putting the imaginary part or the one with an I on this side. So this is how you multiply the complex numbers. Okay, now let's look at the second one, which is the equality of the complex numbers. Okay, the equality operation. Okay, so given the complex numbers, for instance, maybe they can give you like, okay, 3 plus 2 2yi, and this I, if you want, you can put it in front. If you want, you can put it behind. There is no problem. Don't get stuck if you find such cases. So let's say they're giving you this and they have equated it to, this is a complex number. There is an imaginary part and the real part, and then they have equated it to 2 plus, maybe let's say 4i. Okay, and I think here, let me put x here. Let me put x. Okay, so every time you see an equal sign being used on two complex numbers, this is a complex number because this is a, this is bi. This is a, you consider this to be your a, and this is your bi. Okay, b can be any number, like I said. So every time you see that there is a complex number a and there is a complex number a and they are being separated by an equal sign, just know that it is same as saying that the real part of this complex number on this side, left hand side, is equal to the real part of the complex number on the right hand side, and the imaginary part of the complex number on the left hand side is equal to the imaginary part of the complex number on the right hand side. Now what do I mean by that? Let me write it down. So every time you see anything written like this, there is a complex number e equated to a complex number e. It is same as saying that this tree, the real part e, it is equal to the real part that is e. Okay, even this one e, the imaginary part of this complex number e, which is 2yi, it is same as the imaginary part that is on this side, which is the 4yi. But the I sign this one, it cancels because it is present on both sides. So you can just cancel this. Okay, and you're going to have 2y. You can even find the value of y. Just divide by 2. Okay, so you're even going to have 2. Here you're going to divide by 2. You can even have x as your 3 over 2. So that is the principle. you'll be seeing it being applied. Actually, you just find that there's an equal sign. You just see someone starting equating. Okay, so you equate. It is a principle. That's what it means. For any complex, for two complex numbers that are equated to each other, it means that for them to be equal, this is equal, these two are equal, and these are equal. Okay, that's what it means. The moment you use the equal sign, you've already stated that principle. It is a principle and it should always be applied. Okay, and we will be applying it on questions that will be involving finding the values of x and y. Okay, so I've talked about the equality operation. Okay, now I'm done with the operation. Let me talk about the other part, which is the division. Okay, division of complex numbers. Okay, so there is a rule. It's not a rule, it's a law that okay, let me give you an example. Imagine you have a1 plus b I. Actually, let me put 1a, and you have a2. I'm just giving an example. Imagine these two are complex numbers and they are being divided. That's what it means, division. This divided by this. Okay, you have a2 and b2i. Okay, so now you are dividing them, right? So now there is a rule that says that every time you see a complex number on the denominator, you need to find the conjugate of this complex number and divide it with the numerator and the denominator. Okay, it is a law. Every time you see anything written like this, and how do you know that the one on the denominator is a complex number? By looking at the I. If there is the presence of an I, or if there is any number having an I, just know that this whole thing is a complex number, and you have to do the needful, which is finding the conjugate. So now, before I even go any further, let me talk about the conjugate. Okay, let me talk about the conjugate of a complex number. Conjugate of the complex number. So how do you find the conjugate of the complex number? How do you do it? So first of all, the conjugate of the complex number is represented by two symbols. The first symbol is this one, is letter z with a straight line there above, or letter z with an asterisk. Now at your level, you don't use this unless you further your studies. Okay, I know if you're reading some big books, you'll be finding this and maybe you might get puzzled like, now what is this? So this is not at your level, not even a lecture. We use it we use it when teaching in your class. Let me say when lecturing, because they don't teach, they just lecture, right? So you won't be seeing this being used. I'm just teaching for learning purposes, for those guys who like studying beyond. Okay, like this is not used at your level. Okay, but just be familiar with it. Okay, but if you want, you can use it to threaten maybe your friends that, okay, you even know some of the stuffs, to just confuse them. But your lecturers know these stuffs, okay? They know these stuffs. Unless for you guys who further your studies, you're going to be using this often. But the one that will be getting used is this. Actually, if you go through the tutorial sheet, maybe they'll tell you that find z. Maybe they might give you like, okay, z is equal to 2 plus 4i. Then they tell you find z. You even get confused. But what's the difference? What should I find now? The moment you say a straight line, just know that they are talking about the conjugate. Okay? They're talking about the conjugate. So, let's say you have been given z, and then you have 2 plus 4i. Okay? So, to find the conjugate, you just change the sign of the one having an I. Okay? You've changed the sign of the one having an I. So how do you do that? So meaning that you're going to say my conjugate is 2 minus 4i. You found your conjugate. So this is what you now have to multiply throughout. You multiply with the numerator and the denominator. But don't worry, right now I'm just about to dive in the tutorial sheet and solve some of those questions that I showed you, because with just what I've just explained right now, the multiplication, division and the equality, we can now solve the equations. Okay, from the tutorial sheet, we can solve some of the examples actually from the tutorial sheet. Okay, so like I showed you, so let's say maybe for this one here, the conjugate, you're going to change the sign, that is a. So mean that you're going to multiply now a2 minus b2i. You multiply with the numerator, the conjugate. The same conjugate, you also multiply it with the denominator. Okay, a2 minus b squared I. I'm going to solve a realistic example. Right now I'm just trying to give you a bigger picture so that you can understand everything. So now you're going to multiply, and that's the reason why I told you the multiplication of the complex numbers, because it is used when you are dealing with the multiplication of the conjugates. Okay, like in this case, you'll be required to use what I've just told you on the multiplication. So if you're not understanding anything, you should be rewinding the video, make sure that you understand, because everything that I'll be using while solving those questions will be depending on what I've just taught here on the basics. Okay, so now I think let me not waste time on talking unnecessarily. Let's just solve some of the questions in the tutorial sheet. Okay, so let's solve these two questions. They're saying that find the following quotient. The quotient is what you get after you divide. Okay, so here they want us to divide and express the answers in standard form. Okay, so let's solve the first one, this one here, then we go to this one there. Okay, so like I said, the first rule is that you find the conjugate. You're dividing. Remember, this is a complex number. It has got the I, the imaginary part. So find the conjugate. Find the conjugate. So you're going to write to z there, and then you change the sign, that is a. So you're going to have 2 minus 3i. The sign changes, right? So this is the conjugate. Now you multiply this with the numerator and the denominator. So you're going to say 4 plus 7i over 2 minus 3i. And then now, let me write that properly. 2i times 2 plus 3i times 2 plus 3i. And one more thing, after you multiply, you multiply the numerators, the denominators, when you evaluate, you shouldn't end up with any I. Okay, there shouldn't be any imaginary part on the denominator. If you end up with an imaginary part on the denominator, it will mean that you've done something wrong. Okay, always remember that. So you're going to begin. So the numerator, let's begin with the multiplying the numerator. So you're going to say 4 times 2, like I showed you multiplication on the complex numbers. So 4 times 2, that is going to give you 8. Okay, so it is going to give you 8, and then 4 times 3, that is going to give you plus 12i, and then 7 times 2, that is going to give you plus 14. 7 times 3, that is going to give you, now look a, you have an ia, so you're going to have I squared, so you're going to have 21 I squared, 21 I squared. Let me write that again. 2 plus 12i plus 14 plus 21 I squared. Okay, and then divide by, now multiply the denominator. So you're going to say 2 times 2, that is going to give you 4. 2 times 3, that is going to give you 6i, and then negative 3i times 2, that is going to give you negative 6i. Okay, and then now negative 3 times 3i. So first you're going to multiply, you're going to get negative 9. Okay, now I times I, that is going to give you I squared. Okay, so let's simplify the numerator first. So you're going to have 8, let's collect the like terms. 8 plus 14 and plus 12i. Here this one is like you're going to replace where there is I squared with a negative 1 mean that you're going to have negative 21. Negative 21. So first we're going to evaluate that. So now here at the denominator, these are going to cancel. Actually here is we have squared because we're multiplying this times this. Okay, so these are going to cancel because positive 6 plus negative 6, that will give you 0. Okay, so mean that you're going to remain with 4 minus 9 with a negative a. Okay, as I said, why this I squared replaced with the negative 1. Always remember that identity, very important. This identity a, very, very important. Okay, so now let's proceed with evaluating. So now when you add 8 plus 14, you should get, so you're going to get 22 minus 21 plus 12i. Okay, so let me just simplify that further. And then 22 minus 21, that would be 1 plus 12i. This I should be on this side because the imaginary part should be on the right hand side. Okay, and then when you simplify this, you're going to find that this times negative, you're going to have positive. So here you're just going to have positive 4 positive 9. You can simplify this further. So you're going to have 1 plus 12i over 9 plus 4, that will give you 13. Okay, so you've evaluated. Okay, so now they have said that leave your answer in standard form. So the standard form of leaving your final answer, as you can see, I said that after evaluating, you shouldn't end up with anything having an I, any number having the I. There shouldn't be any imaginary part, and that's the purpose of doing this. Okay, is to not end up with an imaginary part on the denominator. That's the main reason for this law the law of multiplying with the conjugate. Okay, now the standard way of leaving your answers is by writing. Remember, there is a concept in mathematics that a plus b, given that you have a plus b over c, it can be written as a over c plus b over c. Remember that. So even a is like you have a plus b over c, you can write this down, you can break this down as 1 over 13 plus 12i over 13. And here, if this can enter into this, or maybe they have a common factor, you can simplify further. So this is the standard way of leaving your answer. This is how you solve this kind of questions. Okay, so let's solve the other one, the last one, on the first question. The other question that you have is this one. So now, in a case where you just have an imaginary part a, it has not been added or subtracted to any number, like maybe 2 plus 4i, it is just alone. You don't need to change anything. You don't need to change any sign. Okay, just get this. So this would be your conjugate. Okay, this becomes your conjugate. So you can just say 4i. But even if you change, but you just don't have to change because it won't affect anything. I mean, the imaginary part will still going to cancel. You won't end up with an imaginary part after you simplify. So you're going to multiply the top and the bottom with 4i. Okay, so now 4 times 3, you're going to have 12i, and then now you're going to say negative 5 times 4, that is going to be minus 20i squared over 4 times 4, that will be 16, right? 16i squared. Okay, 16i squared. And then now you're going to remember the identity, I squared is equal to negative 1 there. Okay, so now you're going to replace for this I squared with negative 1. So we're going to have 12i minus 20 negative 1 over 16 negative 1. Okay, so you're going to have 12i minus remember, negative times negative, you're going to have a positive here, so you're going to have 20 there, and then over 16. And so now, remember I said that complex numbers are written in the format a plus bi. The imaginary part should be on this side. So you're going to just take, they're going to swap sides. This one is going to be a, and this one is going to be, the 12i is going to be on the other side over 16. Okay, so now you're going to write in that form. You're going to split them. So you're going to split them, meaning that you're going to say 20 over 16 plus 12i over 16. Okay, so now you know that these two have got a common factor, right? 4 can enter in both. 4 in 20 is, it goes there 5 times, so you're going to write 5 there on the numerator. 4 into 16 goes there 4 times, plus again these two have got something in common, which is a 4, right? 4 goes 3 times into that, and 4 goes 4 times into this, into 16 I there. So you can even simplify further, like I said in the previous video. You don't just need to end a. If you know that they have common factors, you can simplify further. So we have solved the second question, which is B. Now let's solve the question 2. Okay, so they're saying that solve for x and y. X, they have given you, we have 2 questions. So we have this being equated to this. Okay, if you want, you can try to pause the video and just try to solve, then you compare the answers. Okay, let me solve them since you don't want to pause the video and try them out. Okay, so let's solve question A. Question A, u of x plus iy 4i then equal to 8. Okay, so first of all, you need to simplify this. What do you have A? As long as there is an I A, this is a complex number. Like I said, this is same as having 0 plus 4i. Okay, if they just write 4i, just know that behind the scenes you have got a 0a. So this 0 is A, this is B. So it still remains your complex number. Okay, so you have 2 complex numbers multiplying. So first begin by multiplying the complex numbers. So you're going to say 4 times 4i, that will give you 4xi. You're done. So now multiply this with this, you're going to have plus, that will give you 4yi squared. Okay, so now here where you have I squared, remember that I squared is same as having -1, right? So where there is I squared, you can replace with -1. So you're going to have 4xi plus 4y. Here you just put -1. Very important, this identity is very important. If you don't know this identity, then you don't know this topic. Okay, so now you're going to say 4xi. Where there is plus, negative times positive, it will be negative here now. So for y, let me just write things properly. So now you're going to have 4i there. Okay, now remember that it's been equated to 8. So this can be now arranged properly. Remember complex numbers. Okay, so let's put this on this side. So you're going to have -4y plus 4xi been equal to 8. Okay. Now this is a complex number. This, what you have A, is like your A, plus what you have A is like your B. Okay, and this is the I there. It's been equated to 8. So that's true that I told you, the rule of equality. You can only equate a complex number with a complex number, and once you equate them, it will mean that the real is equal to the real, the imaginary is equal to the imaginary. So here we have a real. Okay, we have a real. There's no way you can equate a real with a complex number. Even that real, we are going to consider that complex number that it has behind the hood. Like I said, in this case, you are going to assume, okay, I have a real number A. A real number is also part of the complex number. So for the fact that it has been equated to a complex number, I'm going to assume that even the imaginary part is there, but it's just that it is 0I. Okay. So now things are balanced now. You're now going to equate the real part with the real part. The complex part, which is this part A, with the complex part, which is 0I. So begin by equating, let's begin with the complex part this time. I mean the imaginary part, the imaginary and imaginary. So you're going to say 4xi equal to 0i, the i's cancels, you're going to have 4x equal to 0, divide by 4, and then you're going to have 4 equal to 4 equal to 0 over 4. 4 into 0, that will give you 0. So x is equal to 0. Makes sense? So now let's go on and find, now let's equate now the real parts. So for the real parts, the real part on the left hand side, you've got negative 4y. It's been equated to 8, right? Okay, so now divide through by 4. We want to make y the subject of the formula. Remember, they want us to find y and x. So divide through by 4. Now you're going to have y is equal to 8 over neg 4. Neg 4 into 4. 4 goes twice into 4, into 8, right? And there's negative, so you're going to have negative 2. So in conclusion, you can say that y is equal to negative 2 and x is equal to 0. You find the values. You see how we apply the concept. Very interesting, right? So let's solve now the last question. I think is quite involving. Let's solve it. Okay. So let's proceed. If you want, you can pause the video and try it out. I know you people don't even post videos. Okay, let me just solve it. So, as you can see, we have this fraction A and this fraction A. So, first of all, we're going to find the common denominator. So, you're going to say x plus iy, and here you're going to say 1 plus 3i. So, what you're going to do now is that you're now going to say this into this. You're going to have you're going to get this back. You're going to have 1 plus 3i. Okay, plus a, it's gonna cancel, so you're gonna get that back there. You're going to have x I y. Okay, so now in short, you have to leave this in a single fraction. So after you do that, then you're going to say that there at the numerator you have 1 plus 3i plus x plus over x plus iy 1 plus 3i. Okay, and then now equate to 1. You're equating to 1, right? Okay, so here what you can do is that I think before I proceed, okay, so you're going to cross multiply. Okay, you're going to cross multiply. So this times 1, you're going to have 1 plus 3i plus x plus I y is equal to this whole thing times 1. You're going to have x plus iy, and then 1 plus 3i. Okay, so you have this. So now look what you have here. This is a plus a. Okay, so here you're going to expand this side. You're going to multiply this times this. Okay, so I mean that when you do that, you're going to figure out that you're going to have x times 1, that will be x times 3i, that will be plus 3xi. Okay, this times this, you're going to have plus it will be I. Okay, this times this is going to be, it is going to be 3y. Remember I and I, that would be I squared. Okay, so you're just going to write the way they are. You're going to have 1 plus 3i plus x plus iy. Okay, So now remember that there is I squared there, so you're going to have plus 3. We are going to replace with a negative, meaning that negative times positive. So here there's going to be a negative. So you're going to have 3xi plus iy, and is equal to negative 3y, like that. Even on the other side, you're going to write plus 3i plus x plus iy, like this. So now, as you can see, at this point where we have just reached, there are some terms which are also found on this side. For instance, this xa is also on the other side. Okay, so you need to compare. If there's anything that is found on both sides, on this side and the other side, they can be cancelled. Behind the scenes, it's like imagine, for instance, you have xa and you have xa, positive x and positive x. If you were to take this x on the other side, it's going to be negative x, right? Imagine, let's say maybe this one goes on the other side. You have plus 3i plus x plus iy, and then you decided to take this one on the other side. You see, here is going to be, here is positive, but when it goes on this side, it would be negative, right? So meaning it would be negative x plus positive x. That will give you 0. Okay, so that's why, in short, you just see that, okay, if there is anything that is on this side and it is also on the other side, you just cancel it. So in our case, x you cancel because it's also on the other side. What else is found on both sides? The other thing that is found on both sides is the I and Y. You have IYA, this one A, and IYA, this one A. So you just cancel them. Okay, you remain with what is not found on both sides. Okay, so now what have you remained with? Can you just write it down? So let me write it down for you. So plus 3i, you just have 1 plus 3i is equal to, you have 3xi minus 3y. Okay, now you remember what I told you, that every time you see, now here you have complex numbers here. You have complex numbers, imagine, plus 3i equal to, actually this time, this one, write it like this, plus 3xi. Okay, now you have complex numbers, and according to the rules or the laws of equality sign used on two complex numbers, if two complex numbers are being equated to each other, it means that the real parts, in our case, this real part is equal to this real part. So it is same as saying that this one is equal to negative 3y. Okay, so by just writing like this, we even have an opportunity to find y. How can we do that? You divide through by negative 3, divide through by negative 3, and then now they are going to cancel, right? You're going to have y is equal to 1 over negative 3. Okay, you have that. So you've just found your y. Okay, and then what else is that the imaginary parts are equal. So it is same as that this imaginary part a, which is 3i, it is equal to the imaginary part that is on this side, which is 3xi. I told you that you get rid of the i's, so you're just going to have 3 is equal to 3x. You divide through by 3, you're going to have 3 equal to 1. Okay, so in simple terms, according to what we have found, we've just figured out that the value of x is 1, the value of y is negative 1 over 3. This is how you do it. Okay, so I'm pretty sure by now you are very confident enough to solve this kind of question in the past papers. So I wanted just to introduce you to complex numbers and try my whole level best to break them down for you, simplify them for you, teach you everything that you need to know. And now use this video as a stepping stone to help you understand now further concepts. Apart from this, there is also other concepts. For instance, finding the square root of a complex number. They like bring that on the exams. And then finding they can also ask you about finding the magnitude of the complex number, how to draw the angle diagram, all those concepts. But you don't have to worry. You can just join my tutorial group. There are already those lessons. You're going to find them in your actual own pace. There are already recorded videos of those topics, and I've solved like the whole tutorial sheet of complex numbers, including the solutions for the tutorial sheet, the written ones in PDF form. I have solved all the tutorial sheet. You're going to find them in the group, including the video lessons. So you can just join my tutorial group. You're going to find the lessons. I would have taught everything in this video, but it will be very long because those concepts just require their own videos. Okay, but the videos are already there in my tutorial group. You can join my tutorial group. To join my tutorial group, you can simply contact me, or you can just text me on WhatsApp on this contact number, which is plus 26025 is 414. Okay, I'll add you in my group, and I offer lessons in biology, chemistry, physics, and math, where I simplify complicated concepts like this one here, and I'll expose you to the target questions because that's where questions come from. And I use this approach when I'm teaching. I like exposing my students to the target questions because they can help you to strengthen the knowledge, and they can make you confident to solve any kind of questions. So I hope that you've enjoyed this video. Don't forget to subscribe, and I'll be dropping more videos like this, and I'll be simplifying more complicated stuffs. Okay, and if you have any opinion, feel free to share it in the comment section. And if you like the video, click on the thumb up button. I hope that you have enjoyed and you have understood anything. And if you have any question, feel free also to leave in the comment. I'll reply you. And have a very nice day, and I hope that you have enjoyed.